So Shapes of Molecules Part 2, just going to talk you through some examples, how you draw different molecules. So first example, silicon tetrafluoride, which is a neutral molecule. So silicon is the central atom. It's got 4 electrons in its outer shell, so it can form 4 bonds. Fluorine has got 7 electrons, can only form 1 bond. So then I always draw the dot and cross diagram first. That really gives me the idea of what shape it is. And so I've drawn the dot and cross here, silicon sharing 1, fluorine giving 1 back. You don't need to draw the electrons around the fluorines or the lone pairs because it's around the central atom we're interested in. So it's got 4 bonding pairs according to the dot cross diagram. So that means it's the tetrahedral structure. So you draw that structure and that one's done. Negatively charged molecules, for example NH2-, a bit more difficult this one. So nitrogen is a central atom, it's got 5 electrons in the outer shell, hydrogen's only got 1, it can't be a central atom. So, but there's a negative charge, so we need to add 1 electron. Negative charge, add 1 electron to the central atom, so that makes 6 electrons. So I start my dot and cross diagram by putting 6 electrons in the outer shell. But the red one there is just showing the extra electron. It doesn't need to be a different shape, it's just to help you work it out. It doesn't have to be a different colour. I'm just doing that too in this video. So then pair up with the hydrogens. So we've got bonding pair of electron here between the nitrogen and the hydrogen, and here as well, so 2 bonding pairs, and then we've got 2 lone pairs of electrons as well. So what shape is that? Well, 2 lone pairs, 2 bonding pairs means it's V-shaped, so it's like water. So you draw the NH2- like water, so bond forward, bond back, 2 lone pairs, and I put a minus charge on as well, square bracket minus charge 2. What about positively charged ion? For example, NH4+, ammonium. So again, N is the central atom with 5 electrons. There's a positive charge, so we're going to lose 1 electron from the central atom. So you can see you've got 4 circles for the nitrogen electrons, then pair up with the 4 hydrogens. So it's 4 bonding pairs, leads to a tetrahedral structure. So draw a tetrahedral structure like CH4 in the other video. 1 H forward, 1 back, 1 to the side, 1 straight up. That's the diagram there. We could also talk about bonding angles as well. If it's tetrahedral, we know it's 109.5, just like in methane. Going back to NH2-, this would be 104.5 because it's V-shaped. And again, this SiF4 would be tetrahedral, 109.5. The last one, a bit more complicated, this one. So this is IF4-. So this is an atom with 8 electrons in their outer shell. It's possible, and this is called expanding the octet. So the IF4- sign. So iodine has 7 electrons because it's in group 7, plus 1 electron because it's a negative charge. So space these 7 electrons around the atom, add the extra electron there. I've put it in red for the new electron. Pair up with the fluorines. Now remember, fluorine can only share 1 electron each, and wants only 1 electron back. So we got 4 bonding pairs of electrons there, and we got 2 lone pairs. So 2 lone pairs and 4 bonding pairs, that is a square planar shape. So we drew the XE F4s then on F4 in the other video. So 2 lone pairs go opposite each other because they repel the most, and then we're going to have 4 fluorines, 2 fluorines forward, 2 fluorines back with a minus charge. And so it's square planar, 90 degrees.